Good morning, friends. I, Professor Arvind Meddeviha, welcome you to the subject Design of Machine Movements 1. In the previous video, we have come across the design procedure for the knuckle joint. Okay, and now we are going to do the design of knuckle joint for the given condition. Okay, so let us see the problem. Here we have the problem statement. Design and sketch the assembly of a knuckle joint to connect two mild steel rods subjected to an axial pull of 100 kN. The allowable stresses for the rod and pin are 100 megapascal, 130 megapascal and 60 megapascal in tension, crushing and shear respectively. The bending of the pin is prevented by selection of proper fit. Okay, so this is the given problem, and if you look into the given data, it is given that axial pull of 100 kilonewton is there on the end of on the rod, steel rods. So P is equal to 100 kilonewton, which can be written as 100 into 10 raised to 3 newton. And the tensile stress, compressive stress, and shear stress are given respectively as 100 megapascal, 130 megapascal, and 60 megapascal. So with this given data, we have to do the design for the knuckle joint. So start with the design of the rod and the rod end. We have equation number 4.19a, which is the tearing resistance of the rod, which is given by P is equal to pi by 4 d square into sigma t, where P is equal to the load, that is 100 into 10 raised to 3 newton, pi by 4, d square is the only unknown, and the sigma t is given as 100 megapascal. So substituting this, we get value of diameter of the rod as 35.68. So approximately we can write it as 36 mm. Next we have diameter of the rod end, which is given by S is equal to S1 is equal to 1.2 times the diameter of the rod, and this value we have taken it from the proportion table, and according to this, diameter of the rod end will be 43.2 millimeter. Approximately we can take it as 44 millimeter. Next we have design of knuckle pin. From equation number 4.20a, the resistance to shearing of pin P is equal to pi by 2 d1 square into tau, where d1 is the only unknown in this equation. Therefore d1 is equal to, we calculated it as 32.57 mm. Approximately to the next even number, we can take it as 34 millimeter. So here we also know that diameter of the pin is equal to diameter of the rod. Here diameter of the rod is 36 mm. Therefore diameter of the knuckle pin small d1 is equal to 36 mm. As we discussed in the design procedure, we have to select the larger value between them. Therefore we have selected the larger value. Therefore diameter of the knuckle pin will become 36 mm. Next we have diameter of the pin head. From the proportion table, C is equal to 1.5 times the diameter of the rod. Therefore it is 54 mm, which is also equal to diameter of the collar. Next we have thickness of pin head. Capital E is equal to d by 2, which is 0.5 times the diameter of the rod. This equation we have taken it from again from the proportion table. Therefore thickness of the pin head is equal to 18 mm, which is also equal to thickness of the collar. Next we have design of eye. From the proportion table, we have thickness of the eye F is equal to 1.5 times the diameter of the rod. Therefore thickness of the eye is equal to 54 mm. Next we have equation number 4.21b, the tearing resistance of the section across the eye and along a plane through the pin axis. P is equal to F into D minus D1 into sigma T. So here the only unknown in this equation is the diameter of the eye, capital D. So substituting the values of other known parameters like load 100 into 10 raised to 3 Newton, F value, that is thickness of the eye 54 mm, and small d1 36 mm, and the tensile stress 100 mm. We calculated the diameter of eye as 54.52 millimeter. And according to the proportion table, we have D is equal to 2 times the diameter of the rod, and according to this it is 72 mm. So again we are going to select the larger value here. Therefore diameter of the eye will be 72 mm. Next we have the resistance of the rod end to crushing, which is given by equation number 4.21 as P is equal to F into D1 into sigma C. Substituting the known parameters like load is equal to 100 kilonewton, F value thickness of eye is 54, and the small d1 value as 36. We calculate the sigma C, that is crushing stress induced, is as 51.44 megapascal, which is less than the permissible crushing stress 130 megapascal. Therefore, we say that the induced crushing stress is less than the permissible crushing stress. Hence, design of the eye is safe. Next, we'll move to the design of the fork. In this, from equation number 4.21a, the tearing resistance of the two sections across the fork and along the plane through the pin axis is given by T is equal to 2 into D minus D1 into capital B into sigma T. And here we are going to find the value of capital B. That is, we substitute other known parameters like P value 100 into 10 raised to 3, capital D 72 mm, small d1 36, and sigma T as 100, and we calculate value of capital B as 13.89 millimeter. And also from the proportion table, we have 0.75 times the diameter of the rod, and here selecting the larger value as the value of B, here we are going to select 27 mm as the value of B. Next, the resistance of fork end to crushing is given by P is equal to 2 into B into D1 into sigma C, which is given by equation number 4.21b. Substituting the parameters like value of load P, D1 and B, we calculate the crushing stress induced in the fork. So here the calculated crushing stress is 51.44 megapascal, which is less than the allowable crushing stress 130 megapascal. So induced crushing stress is less than the permissible. The design of the fork is safe. Next we have the tearing resistance of the square section, which is given by equation number 4.20b as P is equal to d2 square into sigma T. And here the only unknown in this equation is value of d2, which is calculated as 31.62 millimeter. We also know that d2 is equal to S is equal to S1, that which we have calculated in the beginning, that is diameter of the rod end. S is equal to S1. So d2 is also S is equal to S1. Therefore, selecting the larger value here, we write value of d2 as 44 millimeter. Next we have tearing resistance of two sections across the fork, that is P is equal to 2 into capital A into D2 into sigma t, which is given by equation number 4.19d, and substituting the known parameters like load and value of D2 and sigma t, we calculate the value of A as 11.36 millimeter, and from the proportion table we have A is equal to 0.6 times the D. Therefore, the value of A becomes 21.66 millimeter, approximately 22 mm. So, considering the larger value between them, we select value of A as 22 millimeter. So, this completes the design of the knuckle joint. So, students are informed to go through the video, write your ESN in the comment section, and if you have any queries, you are free to ask your queries. Thank you.